Awesome. Well, hello and welcome to the SUSE Rancher Community's Summer is Open campaign. My name is Robert Surchia. I am a technical evangelist here at SUSE, part of the SUSE Rancher community, and this is Summer is Open. Now, we understand that summer is not everywhere right now, and we also understand that it's not open everywhere. But as we are getting back to some semblance of normal, we wanted to talk about some of our open source projects. This is week 2 of our 7-week series to showcase these such projects. And today we'll be talking about our open source project called Opni. Now, to do that, we're joined by Sanjay Nadhavajhala. I said that correctly. I had to do it slowly to make sure I didn't butcher it because I know how bad it is when someone butchers my name. And Sanjay is an experience in various AI software projects across big tech, based in Cupertino, California, and he enjoys playing basketball. Now, we also have a second guest, Joe Kralicki, and he's having some audio issues right now. And when we get him on board, we will obviously bring him in and do an introduction then. So as we start, Sanjay, thank you for joining us, but I hear you are big into basketball, huge, probably a Golden State fan, which is okay. I'm a Cavs fan. I don't hold that against you. But basketball is how kind of got your path into here at SUSE, is that correct?
Yeah, that's right. I actually met the co-founder, Will Chan, through playing basketball for the last 4 or 5 years, and started discussing how AI can disrupt Rancher, and so came on board and started the Opni project.
Awesome, awesome. So before we start talking about Opni, this is a subset of our Choose Open, and well, what does open really mean for you?
Well, coming from the AI community, open means a lot because a lot of the major machine learning libraries, PyTorch, TensorFlow, they're all open source. A lot of the publicly available data sets are huge for just experimenting. And so coming from that point of view, open source is a lot. And the last few years, learning Kubernetes and using Kubernetes, obviously a lot of that stuff is open source. So I think open source is really disrupting the technology landscape.
Now, obviously, you can't do this all by yourself, even though we know how amazing you are. So you do have a team of individuals behind you.
Yeah, that's right. And we actually have 6 different members on our team and a bunch of different backgrounds, skill sets. So I'm just going to go one by one, introduce them. So we have Amartya, who's a experienced machine learning engineer. We have Craig, who is a co-founder of Rancher, director of engineering. Dan, who's a support engineer, but is becoming a dev for Opni. He has a lot of SRE experience. Joe, who is also a dev Kubernetes expert. Myself and Yingbe are both machine learning engineers. I have a little bit of a software engineering background as well. So really a mix of both like Kubernetes experts with AI people on this project.
Hey guys, can you hear me?
Yeah.
Yeah.
Oh, great. Looks like I don't have video for some reason, but I do have audio. So we'll just have to go with that.
Well, that's quite all right. Ladies and gentlemen, let me introduce Joe Kralicki. Joe, you hail from Rhode Island, is that correct?
That's correct, Rhode Island.
Well, thank you for joining us. You are a giant tabletop gaming fan. So what have you been playing recently?
That's right. Recently, I have been playing a game called Delta Green with some of my friends. It's a cosmic horror style game in the Cthulhu mythos, but it's set in the modern day, so it's a lot of fun. I would highly recommend it.
That's awesome. That's awesome. So let's transition and let's actually talk about why we're here. Opni. So I want to share again for you and let Sanjay kick it off for us.
Yeah. So we're going to be discussing Opni in this session, right? And to motivate why one would use Opni, let me just set the stage. So I'd like you guys to put yourself in the shoes of a Kubernetes operator. You probably use a variety of different tools that each help you accomplish something. And nowadays, there's a plethora of tools available to you, and all of them bring something different to the table. Generally, teams that are using Kubernetes are growing in size and are using more and more tools to aid with monitoring, automation, and collaboration. But as the number of tools grow, IT ops professionals are being flooded with too many incidents, tickets, and notifications. And that's because more and more monitoring tools are being adopted and used. But more tools doesn't necessarily mean more efficiency, because you're being flooded with these false positive alerts. And you typically don't know where to look at when an incident pops up. So timely outage detection, investigation, and resolution remain a major challenge. And that's where we see potential for machine learning and AI to disrupt the status quo. So basically, your Kubernetes clusters are emitting a ton of data, and we believe that this data is not being leveraged today, and that's what Opni is going to do. So there's no existing open source AI ops for Kubernetes, and Opni is AI ops for Kubernetes. AI ops is the application of artificial intelligence and machine learning to IT operations. We're positioning Opni as being next-gen observability. There's many different tools that help you collect logs, metrics, and events. None of them tell you if those signals that are being collected are troublesome or anomalous. And so Opni, in its first iteration, as we'll see in the demo later on, really tells you more than just like what are the logs that are collected or what are the metrics that are collected. It tells you which logs are anomalous or suspicious, and which signals you should focus on. So Rancher already helps users manage Kubernetes clusters, and it comes with diagnostics, monitoring, and alerting. And so it's going to fit seamlessly with Rancher in helping you manage your Kubernetes clusters. Next slide, please. All right, so the current state of log monitoring. So log monitoring is our initial flagship feature. And so why we decided to go with log monitoring instead of something more commonly used metric. So let's say you're using like Prometheus and Grafana, right? There's a bunch of different tools that help you visualize these metrics, and forecasting metrics out into the future is a pretty common task, but a more challenging task is figuring out like what are your logs telling you about your cluster. Typically, you don't take a look at your logs unless you really have to. And so we thought that would be a good area to disrupt initially. So popular tools for log monitoring include like Data Dog, Splunk, the Elastic Stack. There's a ton of them out there, right? And the reason why people use these tools is mainly to search for error logs when an outage or incident occurs, for compliance reasons, and a long-term log store. What's lacking is that when an issue does come up and in a sea of logs, where do you as an operator start looking? Grepping for errors or specific filters is insufficient. It's not good enough for you to figure out what's gone wrong, especially if it's not an incident that you've seen in the past. And you can't really rely on the log levels like info, warning, error. It's just not reliable. It's not going to help you isolate the error or errors that are attributed to the incident. So you can't automatically find anomalous logs in an efficient manner. And there are existing log anomaly tools. So I'll name one of them. So the Elastic Stack has Elastic ML, but to run Elastic ML, if any of you have tried it before, you need to have a little bit of data science background, because you need to set up the models yourself. And so, can you go to the next slide, please?
Sure.
And so what we're doing with Opni is making the AI seamless, and you as an operator don't need to worry about the AI modeling portion at all. And so yeah. So Opni, once again, it's AI ops for Kubernetes plus observability. So when you install Opni onto your Kubernetes cluster, it comes with Open Distro for Elastic as well as Kibana. In the future, once we release metric anomaly detection, it's going to come with Prometheus and Grafana as well. So Opni is right now the goal is to reduce mean time to detection and mean time to resolution. Every Kubernetes cluster emits logs. Kubernetes, the application emits logs in the control plane. etcd emits logs, and the application workloads you're running in the Kubernetes cluster, it also emits logs. So we start off with logs. Yeah, and right now, no one's really leveraging logs in a preemptive manner. It's usually something that you only take a look at after something has gone wrong, right? And so we start off with logs because it's a rich data source. It's not often looked at as a proactive and preventative tool. At most, again, operators set up filters of known error logs if they ever appear, and that would trigger an alert. Otherwise, logs are only looked at after an incident. But because of the massive volume of log messages a system can emit, it's very tedious and challenging for operators to figure out what logs are anomalous or not. So why not have AI do this and tell you what logs you should focus your time on when you're investigating logs? And that's exactly what Opni does in its first iteration. So next slide, please. So currently, Opni features log anomaly detection and will classify every log message in your Kubernetes cluster as either normal, suspicious, or anomalous. This will immediately help operators with the problem of what logs they should start looking at and when they're investigating an incident, reducing the scope of log messages from say 100K logs by 95%. Greatly improves mean time to resolution because it reduces the scope of log messages you as an operator need to look at. And we'll see this in the demo too. Opni allows the operator to consume logs insights as metrics, thus allowing them to set up alerts when Opni marks too many logs as suspicious or anomalous. So just to give a little bit of high level of what's going on within Opni, Opni comes with one pre-trained model that focuses on control plane and etcd logs. This pre-trained model is going to be maintained and improved by Rancher Labs, and it's currently for RKE1, RKE2, K3S, and vanilla Kubernetes clusters. Unfortunately, pre-trained models, it's not for cloud managed Kubernetes distributions, so EKS, GKE, etc. The pre-trained model is representative of the expertise Rancher has in the Kubernetes space, and it will constantly be improved and updated, especially when we get feedback from the community. The control plane etcd logs on your cluster will never be sent to Rancher, so no one needs to worry about that. The model itself is used only for inferencing. So the pre-trained model is only one benefit. The other one is really the cutting edge piece. That's where we have an additional AI models that are automatically learning and adapting to your system's log messages. So your applications and workloads, they emit logs, right? So it's going to immediately start learning when new workloads are introduced or anomalous logs within your workloads appear in the system. It learns what steady state is in your cluster and therefore can mark anomalous logs if and when they arrive. And so I think, Robert, you and I were discussing this earlier, like we probably need another session to do like a more technical deep dive. If anyone out there has questions, I'd be happy to answer, but we'll probably have another session that is more just for it'll be a more focused tech talk on the actual AI modeling. But
yeah, as we set up this call, to do this session, I we had a conversation about it, and I just said to Sanjay, I go, this is just too deep. I need more than an hour. I have more questions, right? Because I hear AI, and the first thing I do is buy a domain because I want to have a side project with something to do with AI, and I got excited about it. I scratched the surface, and I was like, I don't think we can get this in an hour. So we're going to have more on this to come. This is just to get an introduction of what is Opni. So when you have questions, the community can answer those questions. But we will have Sanjay back. I promise you all that.
Yep. And yeah, Joe, what are your thoughts on like the pre-trained model that we've developed?
Yeah, so I think I think both the pre-trained model and the ability for Opni to learn on the fly your workload logs, all those things are really great for people such as myself who are not very familiar at all with AI, right? Or yeah, AI machine learning. Like I'm a programmer, so you know, my background's in Kubernetes and like development. So AI is a little bit out of scope for me, right? So and if I want to like yeah, like you said, some tools like Elasticsearch have the capability to do analysis of anomalies, but you have to program all those things yourself. It's all DIY, so you really have to know what you're doing in order to configure those systems. So what I like about Opni as a developer is it takes care of all that for me. I don't have to do any AI in order for me to get the benefit of Opni to analyze logs and figure out you know what's going wrong.
So for the target user, we can say it would be a Kubernetes administrator or operator, but the benefits of Opni go far beyond that for a developer to go down and actually have the ability to see what's going on in their cluster, but actually see what's going on in their application as well without having to have the knowledge behind, creating models and, doing all that AI stuff on the back end, right?
Yeah, absolutely. So even for developers and engineers, like it's great to be able to have eyes on all your workloads at once to help you figure out, maybe which one of your microservices is causing a problem, or you push a new build and that build might have a bug. So can really help with rapid iteration and rapid development because some of those things can be really difficult to track down otherwise.
And we have the CNCF landscape. It's huge. I couldn't name everything on there. I would be surprised if someone could. But where I was trying to figure out where does Opni fit in with this, in that landscape and with other open source projects?
So Op- Opni it's kind of a completely new space in the open source landscape. So but even though
Mhm.
it's kind of completely new, we've designed the user facing tools to be as Kubernetes native as possible. So people using Opni will be familiar with its workflows and configuration. They'll be able to get right up to speed with how Opni works. Um, without having to deep dive too much into the specifics. So the CLI we have to do configuration and all of our Kubernetes configuration and resources will be familiar to Kubernetes operators.
Awesome. Awesome. Now, are there any large proof of concepts with Opti going on with the customer or anywhere you know?
So we're in discussion with a couple of our largest customers who are all interested in using Opni. So we're really iterating our POC. We've already released our version 0.1.2, which allows users to go in, install Opni into their existing Kubernetes cluster, start getting insights. So right now, if you have a Kubernetes cluster, go ahead and try Opni out. And Robert has designed a workshop for you all to get familiar with Opni. So definitely go ahead and start trying it out.
Yep.
Yeah.
That workshop, by the way, is not for the faint of heart. It does require some, some heavy compute and a heavy RAM on your cluster side. So if your laptop can't handle it, you might need a separate machine. But we got it down to hopefully run on a laptop. But we'll get to that later. Sanjay, are you ready for a demo?
Yeah, can we, before the demo, can we just quickly loop back to the last slide?
Sorry, you
I just
broke
want
there.
to, can you loop back to the last slide? I just want to quickly
Sure.
summarize what Opni is before we jump into the demo.
Believe it's this one.
Yes. So how does Opni differentiate from existing AI ops tools? So like this term AI ops has become very popular in the last year and a half, 2 years. And as we move forward, a lot of new AI ops tools are going to come out. the biggest one that sets us apart is that the operator does not need any knowledge of AI or ML. And you guys will see this when you guys actually try the workshop. It's a single command install and very easy to use. So once you use the CLI, which we're calling Opni CTL, it'll ask you a bunch of different questions, and depending on your answers, it will install Opni based off your cluster configuration. It does not require a high volume of logs to get started. Unlike other tools where you need like a week's worth of logs to even start generating AI models. Again, we come with a pre-trained model. So like that model is able to start inferencing and starts giving you insights right off the bat. The AI models automatically adapt and learn from changes in your cluster. So if you're using some of these other tools, you probably need a data scientist that goes and like tweaks your models every so frequently, just to get your AI ops solution to work as intended. For Opni, you don't. It comes with specialized out-of-the-box models focused on Kubernetes control plane, does not rely on connectors to external observability tools. It's a real-time streaming solution. So really, what that means is like you can continue using your log store, your metric store, and it's going to sit in between, and it only retains a week's worth of data, or up to, I believe, like 50 gigs, something like that. And this is all configurable. So it's relatively lightweight, and it's a real-time streaming solution. And lastly, it's open source. So we want this project to be very collaborative. We want the community to like tell us what are features you want. If our pre-trained model is not working with your logs, definitely like let us know. Give us your log messages that you would like Opni to start recognizing. And yeah.
Awesome. So I need to change presenter, and let me bring you up there, Sanjay.
Yep.
And you are now presenters.
Uh-oh. The Mac is asking me to give this permission. Oh man, give me a sec. It says I need to quit and rejoin. Give me a sec.
Oh my goodness. Okay. And while he's doing that, Joe, you're from the developer side. I'm from the developer side. As you're using this in this pre-trained model, has this given you any deeper insights into how Opni is operating with this trained AI model? So are you kind of, I don't want to say learning by osmosis or vision or something like that, but are you getting more and more exposure to, what it's doing as a developer as you're looking through some of the results coming from Opni? I think I lost both of them.
Oh, sorry. Can you hear me now?
I can. Thank you.
Great. Sorry about that. So yeah, Opni will give you. Since it's based on the Elasticsearch stack, we at least for this version, the 0.1.2, the visualizations we have are based on the Kibana. And we have the Kibana visualization tool, and we have some things that we're going to be showing in Grafana for you. So familiar tools that people will know how to use and might already have installed in their Kubernetes clusters right now. Those visualization tools will be showing you some graphs of how Opni is analyzing your logs. It will show you which logs are anomalous. You can see, kind of spikes in anomalous log activity, and that will give you kind of a good idea of how Opni is reacting to changes in your cluster. You can even inject anomalies as part of the demo. So you can install some let's say a deployment that has a container image that doesn't exist. It will try to
Hey, I'm gonna stop you there. You're going way too deep into our challenges. I don't want you to
All
give
right,
away
all
the
right.
secret sauce. But I think we have Sanjay back. Sanjay, are you back, sir?
Yes, I am. I'm trying to figure out how I can start sharing my screen.
I actually gotta make you the presenter. So by all means, you should have permissions now.
Yes, sir. I can see it. All right. Are you guys able to see the terminal?
Yes.
Okay, so let's start off with just Opni CTL. I'm not gonna do a full install right now because it does take a few minutes, and for the sake of time, I think, yeah, you guys will try this out in the workshop anyway. But I just want to quickly show how you'd be using Opni CTL. Initially you would just do an Opni CTL create to create your Opni resources, and then after that, do an Opni CTL install demo. Once you do that, it will give you a bunch of different prompts, respond to the prompts, and then it will install Opni. So very simple, and you guys will all experience that in the workshop. So let's go to this Kibana dashboard. So let's say you were running the Elastic stack, and we're using Open Distro for Elastic due to licensing reasons. That's maintained by AWS. And so let's say you're using Elastic with Kibana, right? Without Opni, you'd come to this page, and you see that in the last 15 minutes, I'm connected to a cluster that's running this stock shop application. We're running a simulation engine, which is simulating 3 different users, generating traffic. So it's in the last 15 minutes, it's received 35,000 logs, right? And if you're an operator and you come to this screen, first of all, there's no way you're going to explore 35,000 logs. Secondly, you have no idea what's the status of your Kubernetes cluster just with this information. So that's why most operators don't rely on log messages unless they need to investigate something, right? You would typically take a look at your metrics dashboard, see like what are the different metrics that are important to your workloads and to you, what your metrics are saying. But logs have a lot more content-rich information. And so what you can do is once you install Opni, you would go to the dashboard, you would go to the Opni logs dashboard, and you get a bird's eye view into what's going on in your cluster. So right now, I have a very basic cluster set up. We have 3 nodes dedicated to the control plane etcd. We have 3 worker nodes. Again, I'm running this stock shop application. I'm sure many of you have come across this application. It's a demo microservices application. And so right now, the cluster is in a steady state. Again, we're receiving 35,000 logs over the course of 15 minutes. And right now, Opni is telling you that out of those 35,000, there's no etcd and control plane logs to investigate, and there's no workload logs to investigate. So there's 4 panels that we see here. Top left is the most important one. It's the Opni Insights panel. Yeah.
We got some people on the question in the chat saying they can't see your screen, which is let's promote you again. Make sure to ask back and see if it. Okay, we're getting some feedback now that people can't see it. I do apologize for interrupting, Sanjay.
No worries. Are people able to see it now?
Yes. I got 1 through 3 feedback saying we're seeing it. So beyond me, people are seeing it.
Okay. Just to make sure, let me just restart this demo because if people did not see what was going on before, I think this would be helpful. So let me just quickly rerun.
Hey guys, it's CK. There's some people saying yes, some people saying no. So it seems to be a case by case or possibly browser issue. So, but I am seeing several people who say they can see it. So I'll just try to troubleshoot.
Okay, cool. So I won't rerun through everything, but just high level, Opni CTL, depending on your operating system, go ahead and download the binary from our latest release, and you would, just explore it. Back to this screen, if you're an operator using Kibana with Elasticsearch as your backend, if you explore your logs in this discover mode, you would see that this cluster that we're connected to is emitting 35,000 logs in the last 15 minutes. You have no idea what the actual status of your cluster is. You would have to rely on your metrics. So what you would do is you start leveraging Opni. And so Opni, we've installed onto this cluster. This is the Opni logs dashboard. It gives you a bird's eye view into your cluster, what your log messages are saying. The top left panel is the Opni Insights panel. I previously mentioned that there's 3 classes that we assign to each log message. Each log message will be marked as either normal, suspicious, or anomalous. Suspicious means that one of our models has marked it as something might be wrong, but it doesn't mean that it doesn't necessarily mean it needs your attention. Anomalous means that, like, hey, this log message, there's something wrong with it. We want you to look at it. Right now, there are no anomalous logs marked in the last 15 minutes, and that's because the system's in a steady state. Nothing has gone wrong. So what I'm going to do now is I'm going to introduce a failure. What I'll do is I will go into, I'm going to SSH into this node over here and just take down etcd. So introduce an etcd failure. All right, so I stopped etcd on this node, and we'll see almost immediately that if we refresh, that Opni is going to start marking a bunch of anomalous logs. And so we see that this etcd and control plane logs to investigate panel, the bottom left, starts getting populated. And so there's 332 log messages. Again, out of those 35,000 log messages, if you were in this discover mode, you would have no idea something has gone wrong. If you use Rancher and you're over here, actually, it immediately tells us that etcd is unhealthy. But typically there's a delay of anywhere between 1 to 10 minutes for this alert to even show up. But right now it already showed up, so that's a good thing. So what you would do as an operator is you would see there's a bunch of different anomalous logs here. So 2,000 in the last minute, we see a huge spike in anomalies. So that tells you as an operator, like, hey, I need to investigate this. So what you would do is you just maximize the panel. You see there's something related to the etcd. If we take a look at the actual log messages itself, it says failed connecting to this IP address. You see that IP address is also appearing in this etcd log message. So, I mean, immediately you could tell, like, if you take a look at this internal IP right here for this node, you see that it's an etcd failure. What you would do as an operator is, like, you would just immediately SSH into this node, investigate your etcd issue, and let's just go ahead and restart etcd. And yeah, Opni immediately tells you where the problem lies, and that's something that you don't get with log monitoring solutions today. And this is just our pre-trained model. So our pre-trained model doesn't need GPUs to run. So let's say you're running, you don't necessarily want the cutting edge AI, which is like learning your workloads, and you just want the pre-trained model. That's definitely an option. You can install it with just the CPU version, and the pre-trained model will run just fine. So as we see, I refreshed just now, no more anomalies that are being marked. And yeah, Opni, within a matter of seconds, again, it's a streaming solution, tells you exactly what's wrong, and it immediately understands when stuff is returned to a steady state, which our cluster now has. So Robert, this might be the first time you're seeing this. Do you have any questions?
No, actually, I got to play around with it when I was building out the labs. I got to play around with it, but I was not going, as deep as to just take one thing offline. I was actually deploying, I had deployments that were in there with no container images, so I was getting that issue and that error. So it comes in slightly different when you have that type of anomaly. So when we built that demo, I get to see that this was quite different, actually breaking Kubernetes and saying, hey, this is something that's real that you're going to see.
Yeah. And
Awesome.
so what I'm doing right now is I just deleted I mentioned earlier that I'm running this sock shop application. So this is a microservices application. And what I did is I just deleted one of the databases that is like a core component of the system. And an AI model has like already learned what the sock shop steady state is. And so the moment that we took down the MongoDB that's handling all orders within this this sock shop application, we see that this log message was marked as suspicious, that there's a Mongo related error. You can't connect to the orders DB. So once again, Opni is able to catch this immediately. And that's really the reason why you would use Opni initially. So now imagine that Opni is able to, in the future, in a few months, it's going to be doing this for metrics as well. So what we're working on next is we're improving this log anomaly pipeline. We have metrics. So within your Grafana dashboard, if you're using Prometheus, you have your metrics, right? So we're going to start forecasting metrics out into the future, like what it should look like, and you'll get a very similar user experience, in which we'll start identifying points in time where we believe that metrics are behaving abnormally, and then down the line we'll start correlating both logs and metrics, so that way you can start doing root cause analysis with Opni.
So Opni actually learned that it knows the happy state of your application, because it learned the sock shop application needed this MongoDB, and it knew it was there. And as soon as it detected it, it knew that there was a problem, because it knew its happy state and automatically realized that that wasn't it, but it learned it on its own, correct?
That's correct. So one of our models is in charge of learning steady state, like what is a steady state, right? So that model is in charge of that. Our other model, which is the deep learning solution, once the initial model, which is trying to understand what is steady state, what is not steady state, once it understands that we're in a steady state, it kicks off a signal to our deep learning training routine, and so that deep learning model, which is like the cutting edge AI, it starts learning the semantic meaning behind these log messages in a normal setting. And so once it does that, it all comes together. And so I'll leave that for the next tech talk that we have.
Awesome. Well, I think Joe needs to be re-added to audio, so let me see if I can do that right now. And would you like me to bring up your slides?
Yeah. Are there any questions I can answer while I'm on the screen?
Let's see. From the audience? No, I'm reading through them. I got a lot about, stuff's not working. Let me.
So for anyone that's having technical difficulties, if you want to see like a rerun of this demo, definitely check out opni.io or go to our GitHub page. There is a short demo. It's like a 10-minute demo, exactly the same demo I just did today. And in fact, in the workshop that you guys do, you'll be doing something very similar. So within that environment too, you can try to replicate all the failures I injected, try to observe if Opni is able to pick them up. So, yeah.
We were unfortunately unable to bring Joe back on with audio, some obviously technical difficulties, but I do have a couple questions from the audience, if you don't mind. One of the first ones is the top 3 features that you'd like to see with Opni as we're coming down.
So the top 3 features, so the main feature right now is log anomaly detection, right? And then within log anomaly detection, we're breaking it down into etcd and control plane and workload logs. So workload logs are the ones that we're trying to learn your workloads. etcd and control plane is just general Kubernetes, right? And the community, how everyone can get involved is like, start using Opni, see if like within the various Kubernetes distributions, within the various cluster setups that you can have within Kubernetes, see if the pre-trained model is working for you. If it is, great. If it's not, let us know, so that way we can iterate and improve the pre-trained model, because it's not just going to help you, it's going to help everyone.
Awesome. One of the members of the community, Rohitan, asked can you assign log levels, or can you assign levels to log messages? E.g., why not use errors opposed to suspicious?
So log levels that's just the stream in which logs are emitted to. Like if we take a look at, I don't know, let's take a look at this right here. Let me see if I could find the logging level. So this stream is standard error, which makes sense. But for example, this log message right here that we marked with the Mongo failure, its logging level is info. And if you're looking at just log levels, you would ignore this log message and you would not know that's anomalous. So like, here's a perfect example, right? So relying on logging levels is not enough.
Gotcha. Another question coming in. This is from Mark. Can this monitor more than one cluster of Kubernetes? So I think what he's asking is, can you, if you have two different clusters running and ranchers, obviously controlling those two, can this work and pipe it down to one, or does it treat each cluster as a separate instance of Opni?
So right now, we're kind of approaching this the same way that Prometheus did, and it's going to be one Opni per cluster.
Okay. And another question coming in, how does this differ from Data Dog and Splunk? You mentioned it earlier, but this is much different than those two product lines.
Yeah, so some of the compliance stuff Opni does not take care of. So we want Opni to sit in between your existing solutions. So go ahead and continue to use your Datadog, your Splunks of the world, because they serve their own purpose. Opni, what it's doing is it's adding AI insights in a way that Datadog and Splunk don't right now. And mainly it's because everything is automated. You as an operator don't need to configure anything once you install Opni in terms of the AI modeling aspect. And it's Opni is relatively lightweight. The only demanding resource is if you want the workload logs to be learned and inferred on, you would need a GPU. That's the only demanding resource. So really, we want Opni to sit within your set of monitoring tools. Now, if you find that Opni with the Elastic Stack that's installed with it, as well as Prometheus, Grafana, and all the insights that come with Opni, if you think that's enough, then maybe you would get rid of the Datadog and Splunks of the world, but we're not saying that we're going to replace them.
Awesome. Next question is from John. Do I install this on my local cluster or on a downstream cluster? And what is the impact to my cluster by installing this?
Yeah, so you as a user have a bunch of different options for installing Opni. So you can install Opni into your existing cluster, similar to how you'd install Prometheus into your existing cluster, right? If you want to install Opni into a dedicated cluster, you can definitely do that. You will be responsible for setting up Nginx or traffic. So basically the mechanism to ship logs over from your downstream to the Opni cluster, you would be responsible for taking care of that. What we recommend is that you install Opni into your existing cluster, because that way everything is within the cluster. That's what Opni CTL is really meant for.
Is there any overhead to this? Is going to be nominal, unless obviously you're doing you're going to need the GPU if you wanted to start learning more about your workloads. Is that correct?
That's right. And the GPU part is just half of what Opni gives you. The pre-trained also gives you a lot, right? So if you think that your cluster is only running in spurts and the cutting edge AI model is not going to help you, just go ahead and don't run it.
All right. Brian here is asking, can Opni also have a normal state for a workload that may regularly be scaled up or down, and that only to cite the outside the process of control state? So I think what he means here is it can Opni understand that you're scaling up and scaling down for that good state of what the application is?
Yes.
Awesome. Getting back to Rohitan, he said, I meant anomaly level. As being unable to connect, shouldn't that be more serious than just suspicious? Rohit, I think that was actually in his demo. Actually, I think that popped up to anomalous, beyond suspicious, if I remember correctly. Yeah, so I can see it up there in his graph.
Yeah, so I mean, so what happened here is like this cluster has been learning the steady state for a long time. So this type of Mongo error right here, one of the models, the one that's responsible for learning steady state, has kind of picked this up too many times in the past where it's like, okay, maybe this is like regular behavior. And so that's why we don't see this marked as anomalous. If you try it out within your cluster, I bet it's going to mark it as anomalous. And so why does this mechanism exist? These types of error messages might just be part of the program. It might be a developer issue. So we really designed for this use case where like we don't want to give so many false positives. Like let's say this error message is like common in your system. We don't want to continue the trend of sending out too many alerts or marking too many things as anomalous, because we really want you to set up your alerts with anomaly level equal to anomalous.
So it's almost like the Opni has actually learned that this is a demo app and you can bring it on Mongo, and it goes, well, this happens quite frequently, so this might be okay. Is that probably what happened here?
Yeah.
Awesome. All right, let me bring these. I think we have a couple more slides, and then, kind of a call to action if I want to change presenters back, if you don't mind.
Yeah, go ahead.
All right. Yes. I had to bring my questionnaires up, so it's a different window. All right. So we've seen something similar to this, but as it's coming through now to share, go ahead.
Yeah, so we applied Opni to real K3s outages. Our support team was looking into K3s issue, and they were looking into it for quite some time. And so after the fact, this was back earlier on in the year. So they wanted us to see if like Opni would be able to pick up basically the log messages that they were looking into. Can Opni identify the issue? And so it took them 2 weeks to figure out what's going on. Opni was able to do it within an hour. And so within the anomaly panel, the workload panel at the bottom right, it was able to identify the exact log messages that that rancher got back to the customer with. And if you go to the next slide, there's actually something a little bit more interesting that goes on with these Opni insights. So
there you go.
So okay, cool, thank you. So we overlaid the Opni insights with the metrics that you can see on Rancher, the Rancher server. And so the support team saw that the CPU utilization, a bunch of different system metrics, they spiked around 1031. And Opni actually saw a spike in anomalous logs at 1029, like basically right before 1030. So, and so it just shows that like, log messages have a ton of rich data that oftentimes are not looked at. And metrics they're not a leading indicator. They're always representative of what happened in the past. And so are logs, but logs are more real time. Because metrics are instrumented, logs they're straight up just a log message. So we saw that Opni was able to catch it slightly before the metrics, which we found very interesting. And so, yeah, we hope that people are able to reduce mean time to detection and mean time to resolution using Opni.
Awesome, great. Well, as we're coming to the top of the hour, I want to give an opportunity to talk about the Opne Roadmap, because this is obviously important with any project, especially here at SUSE and Rancher, that we want to know what's coming down the pipe in form and features. So if we may just switch gears just a little bit.
Yeah, so we recently released version 0.1.2, which allows you to full install Opni into your existing clusters and start consuming log insights from it. Our version 2 in the fall, it's going to introduce metric anomaly detection, which will come with Prometheus and Grafana. If you already have Prometheus in your cluster, it will just use that instance. It will also introduce Kubernetes events, so that way within our custom UI, you'll be able to see logs, metrics, events all in one place, and that sets us up to start doing correlation and root cause analysis for later this year / next year. Other areas that we are considering to introduce anomaly detection to is audit logs, root cause analysis, of course. A lot of AI ops tools right now claim that they do root cause analysis, but we see that the common pitfall is like root cause analysis that's not accurate takes more time away from an SRE. Like basically the taking time away from the SRE is the ultimate sin. Unless it's like absolutely accurate, you should not like provide root cause analysis. And so building up with log anomaly, metric anomaly, events, basically stitching together all these different data points that your clusters are emitting. We believe that that's building up from the ground is going to allow us to do root cause analysis better than everyone else. So yeah, that's currently what we have in the roadmap. And of course, like everyone, please join our Slack, give us feedback as you try Opni. If you have any new ideas, post in Slack or reach out to me directly.
So that's a perfect segue. That's a perfect segue into how they can get involved. First, I always stop everybody. Give us a star on GitHub. This is open source currency, so that's a huge one. More documentations, obviously, at opni.io. Sanjay's mentioned Slack. We also have community.suse.com. You were mentioning feedbacks, or what other issues that you face. How can someone get those, back to you? What's the best way? Is this a Slack? Is this an issue they post in GitHub? If they're saying, hey, we're seeing this type of issue constantly with our clusters, what's the best way for them to get back to you with that, Sanjay?
Yeah, best way is to open up an issue in GitHub or head over to our Slack, post in Rancher Opni Slack channel, or reach out to me directly on Slack too.
Awesome. And if you want to follow us on Twitter, Sanjay is at Sanjay920. I'm at Robert Cirque. Obviously, everyone here, if you're on Twitter, should be following Rancher Labs, because if you're not, we'll have to have that conversation. That's where CK is posting some of the latest and greatest information that's coming out of the SUSE Rancher community. Our labs will be posted, or challenges, excuse me, will be posted sometime after this webinar, along with the recording of this webinar. And it's a doozy. So like I said before, it does require a little more compute power and a little more RAM than some of our previous labs, but it's well worth it. And if you can get it working with Rancher Desktop, let's see if you can do that. So let me stop my share here. So office hours will be this Thursday, 1 p.m. Eastern. If you can join me, Sanjay, would love to have you. If not, I'll be there. I'm always there. So thank you, Sanjay. Thank you, Joe, for coming. I'm sure we'll see you guys again. And thank you to everyone who showed up, and join us for next week for our discussion around something that's exciting in the ecosystem right now is Harvester and HCI. So everyone, thank you, and we'll be seeing you in the community.
Thanks, everyone. See ya.
Thank you.